Hi everyone, welcome back to ChemHelp ASAP. Today we are going to introduce the concept of equilibrium, and we will do that by first defining what equilibrium is. Let's get started. The first thing I want to make clear is equilibrium is not static. It is a dynamic state. Second, there are two conditions which must be met for equilibrium to be achieved. The first is that the rate of the forward reaction must equal the rate of the reverse reaction, and the second is the concentration or the amount of all species is constant. Let's first talk about the rates of the reaction. So we'll go with a very generic equilibrium condition where we're going to have A in equilibrium with B. When I write this rate, you will notice I use two arrows. At this point, you're probably used to seeing reactions written with just a right-hand arrow, but in equilibrium, again, it is a dynamic state. You will have a forward reaction of A going to B, but you will also have a reverse reaction of B going to A. This is why we talk about the forward rate and the reverse rate of the reaction. Let's take a closer look at this graph here. We have time on the x-axis and we have reaction rate on the y-axis. Initially, you are going to start with all of species A. So that means the conversion from A to B, or your forward rate, is going to start very high. So if you look at my chart at time equals 0 right here, you'll notice my forward rate is way up here. It starts very high. What is true about my reverse rate? Well, initially I don't have any B, so I cannot have any reverse reaction happening. So my reverse rate starts down here at 0. But given time, as the reaction progresses, we start making some of our product B, which then does start to go back and form product A. So after time 0, I'm no longer going to X out our reverse rate. We will then have B going back to A. So what happens to the rates, again, as time progresses? So let's take a look at this time interval right here. I don't know, let's call this 10 seconds. Our forward rate has decreased. We don't have quite as much A. We still have the forward reaction happening. It's just not happening at as fast a rate. And what's happening to our reverse rate? Well, it is increasing because we have formed more of our product B. Eventually, our forward rate and our reverse rate come together right here, and they are equal. At this time, equilibrium has been achieved. The forward and reverse reactions are still happening though. They are just happening at a rate that is equal to each other. So at equilibrium, if my forward rate is say 1 mole per minute, my reverse rate must also be 1 mole per minute. Now let's take a closer look at concentration. Still keeping our same generic reaction, A in equilibrium with B. Just like before, let's see what's going on at time equals 0. Again, we only have reactant A because no product B has formed. So you can see my concentration of reactants is very high and my concentration of products is 0 at this point. We give this reaction a little bit of time. Again, A converts to B, B starts to convert back to A. And again, let's say this line represents 10 seconds. You can see our concentration of A has decreased, it is being used up. Our concentration of B has increased as it has been being formed. And then when is equilibrium established? Well, it's established when these amounts or these concentrations are constant. So when these curves in my plot level off, that's when equilibrium is achieved. So I would say equilibrium happens somewhere around here. The place where I see students make the most mistakes is not keeping these two conditions distinct and clear in their minds. So our rates must be equal, but our concentrations only need to be constant. So a common question which trips students up is something along the lines of, is equilibrium achieved when my amount of A equals my amount of B? The answer to that is no, because your amounts or your concentrations only need to be constant. They may be equal, but they're probably not equal. But again, they're constant. It's the rates that must be equal. So just be careful that you keep these two conditions very distinct in your mind. So let's take a look at some questions that can be asked about the condition of equilibrium. So we're asked to consider this equilibrium reaction right here. And the question asks, based on the graph below, is equilibrium established, and if so, when? So the first thing we want to look at is what type of plot we have. So in the previous slide, of course, we saw two different plots, one plotting reaction rates, the other plotting concentration or amounts. What is this plot showing us? This plot is showing us reaction rates. What must be true of reaction rates for equilibrium to be established? Our forward rate must equal our reverse rate if we are at equilibrium. Looking at this graph, we can see our forward rate is going down as we would expect. Our reverse rate is increasing, but do they come together? Are they equal at any point in this graph? They are not equal at any point in this graph. It looks like they do start to level off here, but they have not yet come together. They are different rates. So for this question, equilibrium has not been established. Let's take a look at another question. Again, we're given another reaction in equilibrium, and still, based on the graph below, is equilibrium established, and if so, when? So again, we want to look really carefully at this graph. Which type of graph are we being shown here? Well, this is a concentration or amount versus time. So we need to think about what is true about the amounts or the concentration of all our species at equilibrium. Our amounts of all of our species must be constant at equilibrium. They may be equal, they may not be equal, they just must be constant. So if I'm looking at this graph, I want to see where all of my species level off and are constant. It looks like that's going to be about right here or so. These graphs are a little open to interpretation, but I am seeing that my N2 is curving for quite a while there. Another common mistake that I see is students very much focus on this cross right here, where the amount of ammonia is equal to the amount of nitrogen. But remember, equilibrium is not established when the amounts are equal, just when they're constant. It's our rates that must be equal. So you may see a modified version of this question, where instead of you having to identify where equilibrium is, you might be given several lines here and asked at which line is equilibrium established. So you might have these lines A, B, C, and D. They really want you to make the mistake and choose line B, because again, we have this cross. Well, I didn't quite hit the cross, but at that cross, they want students to mix up the rates being equal versus the amounts being constant. And hopefully in this video, I have repeated myself enough times that you can be clear that rates are equal and amounts need to be constant. I hope you found this video helpful, and thanks so much for watching.